Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hello, everybody. So, in this video, we're going to look at the second part of Chapter 3.3 Quality Control. And before we continue, make sure you have begin your lesson with Ummu Kita Al-Fatihah and learning prayer. Okay, alright. So, in this video, we're going to continue from what we have stopped last time. So, last time, we have already looked at the definition of QC. We have covered histogram, Pareto diagram, check sheet, and cause effect diagram. And we have three more left, which are control chart, scatter diagram, and flow chart. So we're going to look them and how we can apply them. And you are expected from the lesson to be able to use Pareto diagram, apply check sheet, cause and effect diagram, control chart to solve basic problems, okay, in equation. So this part here can be out to into your PSPM1 later on. All right. So we're going to look through how to use either of these three, especially. Okay, and the rest, another three, which is our histogram, our control chart and scatter diagram, you should be able to describe them. Sorry, control chart is a part of the we have to apply. Scatter diagram and flow chart, you should be able to describe them. So when I mean by describe, we can take an example. So we just take histogram and example. So you should be able to explain what is histogram. So it's a graphical, it shows the process capability by showing frequency distribution or often each different value in set of data occurs. And if the question asks you to describe, you can also use diagram. So you can draw an example of histogram. So you can draw one of these and then labels and then give some explanation. So you can get marks from diagram and then from explanation. So typically the question can be like can contribute to 3 to 4 marks. Okay, right. But if the question gives you only 2 marks, you can just give one diagram and then 1 point. So it's easy as that. Okay, but in our case, since we are PDPR, so your question most likely will be in objective manner. Multiple choice questions. Okay, therefore, okay, you should be able to remember and understand this. I think it's more important for you to understand. Use when data are numerical to see the shape of the distribution. So make sure you read them and then try to understand. Okay, try to translate in the language that you have more fluency compared to the rest lah. Okay, so we have covered histogram. So just a review. This is how we look. This is how histogram looks like, and then we have looked Pareto diagram. It looks like histogram. Okay, but then it has some arrangement, a specific arrangement, which is declining formation here from the biggest going downward to the lowest, and this one is just a reference, nothing at all. Yes. Oh. All right, and then you have a line graph which represent the cumulative percentage, and in the percentage of this plus this, and you get this. The percentage of this year, and this year plus, you get this one. And then and so on until you get 100% is the maximum, supposedly. Okay, then. Alright. Then we have check sheet. So this is the kind of check sheet we're going to look at. So basically, check sheet, you have like what are the things, what are the types of things, what of the aspect you are looking at, you're observing. So meaning that you are using your observation, what we call panca indera lah, like your mata. Okay, so what you can see, you're going to tick it like this one. Okay, 1, 2, 3, 4, and then at the fifth one kita akan buat slice like this, right? So and then it means 5, and we continue if we have more than that. We are not using numbering during the observation, but after that we're going to make it total, and then the total we're going to use numbers. Okay, So that is your check sheet. And then cause and effect diagram. So this one is, I have explained it last time. It has several names. Ishikawa fishbone diagram. So it's all the same. Cause and effect diagram is the same name. Right, so basically we have effect on this side and then factor and causes in this side. So we start with category or factor and then we describe the factor. What are the things? What are the reasons? What are the punca? Okay, what are the source of problem within that category? So this is standard category, people, material, work methods for manufacturing process. So I repeat again, I want to highlight manufacturing process. So if you're talking about other than that, like construction, we're gonna have different category most of the time. And if you're talking about cause and effect diagram related to human activity, something like, okay, the effect is why student cannot score. Okay, students could not give attention, give full attention during Seraja's lesson. So we take that example as an example. And then you will expect this here gonna change the category. So maybe like category, we're gonna have category like material. So my material not interactive whatsoever. Okay, Seraja's attitude. So let's say attitude. So Seraja's just melepaskan batuk di tangga, something like that. Alright, what else? Seraja's tone. So my tone is like very monotone, just okay class. So very tiring tone, very demotivated tone, something like that. You can describe that. So you're gonna have different. Basically, what I mean is you're gonna have different category for different effect. But this one is a standard one that we're gonna use for if we're talking about manufacturing process. Okay, so it can be like this one here. You're gonna have arrow like here. So it must be arrow. Remember, must be arrow, not just line. Arrow. Meanings why do we need the arrows? Why is not just line? It must always be arrows because we want to show it going towards there. So all these factor here, this cause here, contribute to direct us to, so arrow here, directing us to this one, the effect. Where the causes are people category and it bring us to the one of the to get to the quality to the effect here. So you always must use arrows. So please pay attention on that. Okay. So we can have major factor here and then we can have like minor causes. Okay. Adding on that. Okay. Like branches, like a tree. So here, for example, so you have arrow. Sorry. Let's say you have arrow like here. Okay. And then you have the cause, the main cause. And then you can have the minor cause. Okay, to contribute the contribution to the contribution. All right. Okay, so today we're going to look at, in this video, we're going to look at control chart. Okay, so what if we zoom in the control chart here? So let's just look here what we have. Okay, first of all, we have time here. Time is always the x-axis. It's always versus with time. It's never been different. So this is control chart we use to look the influence, okay, the change by time. Okay, mengikut perubahan masa. So the more the time, when we go straight to the time here. So maybe let's say we start at 8 a.m. Okay, this is too big here. So let's start with here. So 10 a.m. and then here, let's say, we take this example. This is 9 a.m. Let's say. So every 1 hour, you make your measurement, you make your observation. So 10 a.m. So this is an example. So we're talking about time. You can go like by duration, like 5 minutes, 10 minutes, 50 minutes, and so on. You can just use by date, whatever, as long as it's talking about time, a progress of time, timeline, then that is your x-axis. And here is your measurement. Okay, your ukuran. Okay, so things like here. So let's say start here is 10. This is 7. Okay, this doesn't mean negative here. Okay, I will explain later on. It does not mean it is a negative. Okay, this upper here and the lower here, then we have a line at the center here. This is not just talking. This is a process mean. Mean is the average. So the average number after the average reading. So here, let's say you get 10, 7, and then 9, and something like that, and so on. And then you get the average. The average is 8.5. Let's take that as example. So that's why if you got below that 8.5, that's 7, and then you're gonna above 8.5, 10, and so on. So this line here is not zero. Not zero, not necessarily. Sometimes it is zero, but most of the time it's not necessarily zero. Therefore, this doesn't not mean always negative, and above means positive. No. Okay. In this Gantt chart here, the control chart here, we use process mean as our center line here. And then the next thing we're going to look at, we have UCL and then LCL. What is UCL? Upper control limit, lower control limit. Okay. Alright, class. Again, I know I have said this so many times, and I want to highlight again this time as well. Okay. So we don't have, these are the thing that awak dah guna dah pun. But the name is, wow, upper control limit. Ada limit pula, lower control limit. No. This is the thing that you have used. You remember when you make your reading, let's say you said, okay, sir, the reading is 10 mm. So maybe you use your ruler, whatsoever, you measure something 10 mm. And then you say, sir, plus minus. Maybe plus minus 0.5 mm. So what you're saying here, plus minus, means that lebih kurang. So sir, this is my reading, but you know we have parallax error, we have zero error whatsoever. So by taking consideration of that possibility of errors, okay, let's say plus minus 0.5. So it can be between 10.5 to, let's start with the lowest one. 9.5 to 10.5. So within this range. So like, you know, if you go, okay, let's take another example. If you go to like, you are go shopping, so your parent asks you, how much money do you need? So we can never tell the exact amount that we're going to use, we're going to need. Okay, so normally we're going to say, mama or father, mother, maybe like around. So the keyword is around. Ataupun lebih kurang dalam, okay, so lebih kurang. So that is plus minus, lebih kurang. So this is the thing we normally use, not something we don't use. Mother, let's say your father asks you how much money that you need. Father, maybe like the upper control limit is 5 ringgit and the lower control limit is minus 5 ringgit lah. So my mean is like 10 ringgit. So you don't say that like that way, isn't it? So, but that is the thing that we use, the term that we use in control chart. So please don't take this like this is very new, this is different, this is rocket science, this is, we have to understand. No, this is the thing that we have used, but we just name it, we just term it to the scientific terms, or to the mathematics terms that we engineer call it for. So upper control limit is the plus and lower control limit is the minus. So do you know, when you do your experiment in chemistry, in physics, you always see the measurement or some of the reading, it says plus minus here. So do you know this plus minus, the value here, where does it come from? I mean, of course, you can say, boleh kata lebih kurang. But where does it come from? So here is your this, ataupun nak kadang-kadang kita guna ni. So you know what is this symbol is? I'm pretty sure you know it, but you might not be able to relate it. Mungkin awak tak perasan. Okay, you can pause the video and try to think for a while. Take a minute and think, where is this symbol here come from? Okay, and here, alright, you can pause the video about a minute and then you can watch this video again. So if you watch this video again, and this is actually standard deviation. Okay, so do you know where you learn standard deviation? Alright, I'm pretty sure you learn standard deviation in your I think statistic. I think form 4, form 5, I'm not sure, but in your SPM level awak ada statistic, and then matriculation level pun ada statistic, but I'm not sure which chapter. But I'm pretty sure you learn about mean, you learn about minimum. I'm not sure. You learn about variance, okay, which is S kuasa 2, or sometimes we use sigma kuasa 2. Or, and then we have standard deviation. So it's either S or basically it's variance cert variance. So sometimes we use sigma. Alright, so in this here, alright, so I don't expect you to be able to use the formula and so on. What you can do, you can just use your Google, and then put your value here, okay, and then you can just Google here, okay, and then and then make the calculation. So you can straight away get the. So if this is an example of the value I'm using, so I got the standard deviation 4.89897 and so on. So this is about 4.9. So this is my plus minus. So plus 4.9 minus 4.9. Okay. And I think this one also, does it calculate mean? I'm not sure. But you can use your calculator, online calculator, to find out your. Otherwise, you can just use the formula, the standard formula here. This is for your variance. Okay. Do you still remember? Are you familiar with this? Alright. If you're not familiar, please make sure you're familiar with it again. And then just set it later on. So I'm pretty sure you should know this already. Okay, but to make it faster, you can just use standard deviation calculator here. Calculator.net, look at standard deviation. Or you can just Google any. And here. So there's your upper control limit. Basically your standard deviation. And this is your minus. So, and then your value here. So at 5 AM, what is your value? So let's say. So where do you use this often? So try to think. Okay, pause this video a minute. Okay, and then think about where can you apply this quality control tool here. This control chart. Kat mana awak boleh guna? Try to think. Okay, kenapa? Bila kita nak guna? Again, QC tool is actually to help you to discover, to analyze data, and then discover. You should be able. You're gonna use the tool like control chart here. You use to analyze data and decide where are the problem, which is the problem you want to focus at, and then you want to solve one by one. Okay, basically your product. So antara benda yang biasa saya gunakan, alright, or actually engineer use is your internet connection, internet speed. Alright. So pukul pagi, kat pagi ada pukul 8 pagi, berapa speed awak check, and then you so on. You know, all of us must have this experience. Okay, especially those yang playing game. Okay, kenapa hari Minggu slow ataupun waktu tertentu? Like when you play pagi tak ada masalah, bila you main malam ada masalah. I don't know. So this internet speed, we can use this control chart to check our internet speed. Alright, so check, and then after you get all the numbers here, let's say this is 10 Mbps, this 7 Mbps, blah 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 blah. You get the numbers, and then from those numbers you find the mean first. So you can create, and then you may create your mean line. Not mean line first. Okay, jangan salah faham. Bukan mean line first, but you get the reading first, and then from the reading you calculate, or you can just use calculator whatever. Find out your mean here. And then create your line. Then you know, and then you create you check your upper control limit, which is your standard deviation. Okay, plus. Biasanya dia akan plus. Jangan awak ambil nombor je. Kalau saya kata 5, sini 8.5, tak logik lah 5. So 8.5 plus 5, that would be 13.5, isn't it? Okay, and then you minus it. This one is going to be, let's say minus 5. Let's say the standard deviation is 5. Okay, that's 5. So it's minus 5. So this one going to be is it 5? Is it 3? Yeah, 3.5. So 3.5, 13.5. So that is your, you know, at this area, this is not good. And this is good area. Okay, if you get to this point here, this is good area. Right? So when you get this area here, this is what you want to get. So in the next, after you improve, after you have detected some problem. Okay, kita ada masalah dekat sini. Okay, kat this area. So kita tengok waktu kat sini. Apa masalah? What happened during this time? So we solve that, and then we're gonna make another control chart. Okay, after we get another control chart, we're gonna do that the same thing. we're going to create control chart again and again and again. But your upper control limit gonna get smaller. That's supposedly. Supposedly, your upper control limit is smaller. So, if I take this, okay, saya buat sekejap. Saya buang sekejap. Yeah. Okay. Let's take an example. Right. Okay. So, you're gonna make another control chart. Okay. Right. So, this is your time. Alright. So, this is horizontal is time. Okay. So, you make your reading, blah, blah, like this, like this, like this, like this. But, this is your mean. Your upper control limit, okay, your mean might be changed, might be increased a little bit. Let's say, now you get 9.5. And then your upper control limit, your lower control limit should be, okay, should be better lah. Okay, shouldn't be 5. Maybe your standard deviation would be like 3.5. So, meaning that 9.5 out boleh naik. Okay, see, you can get more increase. So, basically, you want to achieve stability. But if you get increment, that's good as well. That's better. That's a lot better. But mostly, we are trying to get stability. So, 9.5 plus 3.5, 12. And then this is going to be 13. Minus 3.5, this is going to be 6. 6? Yeah, it's 6. Right? You're going to 6. So, before this, you can get to 3.5. Now, you want to at least, you're going to get 6. So, that's getting improvement there. So, you shouldn't go more than this. If you go more than this, then this is not what you want to achieve. Something is wrong. You have to revisit and do some changes. Alright, so this is basically about your control chart. I hope you can get out of my explanation. Again, this is not the thing. It looks like very I don't know, complicated and so on, but this is not. This is the thing that you have normally used in your daily life, but we just change it with the right terms. Okay, so this is an example. And then we're gonna have our scatter diagram. So scatter diagram is one of the main tool that typically researcher use, okay, in their research. So you learn about, okay, you use when you learn physics, we have F equal to, okay, let's make it bigger. F equal to ma. I'm pretty sure you learn about this. This is force. So we know that the relationship is if F is going up, if M is increased, therefore F increase. So we get this relationship. Okay. If acceleration increase, then your force increase as well. So you get this relationship. So let me ask you, how do we know this is the relationship? How do we know if we increase mass or increase acceleration, the force will be increased as well? How do we know? Who tells you this relationship? Okay, so actually all this begins with, okay, some research made by researchers. Okay, of course we know F come from Newton's law 1, Newton's first law, second law, and third law, and so on. So we all know about that. But how does it know? How did it know? So did he discover? So by making some research, so maybe he takes some things yang berat, yang has a big mass, or making some acceleration, small acceleration and bigger, and then check the force. So before you can make sure that we have this relationship, you're gonna start with scatter diagram here. So scatter diagram is actually to verify. Okay, right. The simplest way to determine if a cause and effect relationship exists between two variables. So we have two different variables. We have F, one variable, M variable, mass is another variable. So we have two variables. So do these two here, okay, have relationship? I mean, if F increase, M increase, or if M increase, F increase, or if M increase, F decrease, whatsoever relationship you want to call. So we want to see, do they really have relationship? So this is the way we check. We are checking. This is one good way to check between. The relationship between. The relationship, the influence relationship between two variables. So this is scatter diagram. So like this is an example here. Okay. So this, let's say this is F, this is M. So in this graph here, in this scatter diagram, this is an exact scatter diagram. You have point here, point, and then you make a set like an average line. Then you have like y-axis, x-axis. You give some reading, and then you get to the point here, and then point here, and then you get the relationship. What you can tell, what can we tell from this graph here, from this scatter diagram here? We can tell there is relationship. So directly proportional. That is what you get from your research. Okay, this is why we make research. We want to really understand, we want really to prove, we want to give evidence that there is relationship between these two variables. So, okay, like this one, I think this is directly proportional. Ada, maknanya ada relationship. Maknanya kalau X bertambah, Y bertambah. Okay, so we have that relationship. The same goes here. Okay, this is some patterns that we can get. So, this pattern is positive correlation. So, the keyword here actually is correlation. So, correlation means that, okay, so correlation here, correlation, relation. Co means dua-dua, two, okay, relation, so dua-dua berkaitan. So apa berkaitan dia? So this is positive berkaitan, berkaitan yang positif. Positive correlation means that X and Y positif. Maksudnya dia, kalau kita buat relationship, dia ada. Kita boleh kata this, kita ada relationship. Okay, so this can be used as your proof. Okay, nampak ada correlation. And you can apply to other measurement later on, to other value. Okay, and then this is negative correlation. So it still have correlation, not that negative, down. So when X going up, Y going down. X going up, Y going down. That's it. Get the diagram. Okay, no correlation at all means that correlation, X going up, Y doesn't like going down, going up, X going down, going up. So it does not have no correlation at all. So it's just like random. So if we get this kind of scatter diagram, we cannot say we cannot say other relationship. No, we cannot say that. So typically scatter diagram ni awak akan nampak no correlation bila we are studying on something new or something related to social. So meanings like, okay, awak pun buat kajian. Okay, tidur lambat versus, and this is an example. Okay, score for flat. Contohlah. Kemudian awak pun buatlah buatlah kajian. Okay, tidur lambat. So hari pertama awak tidur lambat. Okay, pukul apa? Hari kedua pukul apa? So awak dapat ni, okay, tak ada masalah. So awak tengok tak ada pun correlation. So ada je pelajar yang tidur lambat yang dapat PNJK tinggi. I'm just giving you an example. This is not, I'm not sure it's true or not. You can do that research by your own. Okay, find out. Sebab lagi lain orang lain pula dia punya cita rasa kan. So I'm not sure. So yeah, you have to find out the correlation. So this is no correlation. This negative correlation may exist. So this is not as, like you can see this density here. You say this density, tengok ketebalan dia, kerapatan dia, terlalu rapat dia macam sangat rapat. But this one not really. And this is, alright. So well, you can say there may be some correlation, but it's getting downward, but because the density is quite loose, agak jarak, so we can say may exist. So if we go to may exist, meaning that you have to do more research, you have to use different method to find out to get to your findings. Okay, correlation by esterification. So this is more. This one is, sebenarnya kalau tengok sini ada bentuk yang berbeza. Ada segitiga, ada bulatan, ada petak. Okay, I'm not sure if you can see this. So, esterification ni dia ada buat pecahan lah. Ada kumpulan, strata. So, dia ada lapisan dia. So, lapisan ni, okay, ada kaitan, yang ada kaitan. So, ikut dia punya kategori dia. But using the same scatter diagram. So, this one is curve linear relationship. So, mungkin ada relationship tapi curve. Okay. Very rapidly increase. Okay. Things like duit. Awak buat kajian duit, ada duit dengan stress level. Okay. So you pun buat lah. Kalau tak ada duit sikit, duit habis sikit. Ni kata duit habis. So duit habis sikit, okay lah. Okay, nampak stress dia macam ada naik tapi sikit je, slow je. Tapi bila duit dah habis, start banyak ni dah habis, awak dah start cepat naik stress. Okay, dah habis RM1,000, awak dah start menggelabar dah. RM2,000, RM3,000, RM4,000, RM5,000. Okay, so that is, You have curved linear relationship. So scatter diagram is just want to prove either you have you have relationship or not. Okay, right. So that is your scatter diagram, and I hope you understand that. Alright. So actually in scatter diagram ada kiraan-kiraan sedikit, but basically I wouldn't expect you to go to that detail. Okay, because we are just going to use scatter diagrams to describe. Alright, so last but not least, we're gonna have flowchart. So flowchart is really alright. Okay, we have if we have bureaucratic, I forgot how to bureaucratic relationship style. Okay, alright. Okay, saya relatekan sikit. Style in your chapter 1, 3.1. So flowchart sangat rapat dengan bureaucratic. Okay, just want to say that. Kenapa dia ada process? So flowchart is always we're talking about kita ada specific process. Okay, so it is a schematic diagram. So basically schematic ni dia ada ni maksud dalam diagram tu, ada dia ada maksud dia tersendiri. So it's schematic diagram, mana kita guna rajah that shows the flow. Dia nak siap produk tu apa flow ni. Okay, or services as it moves through the various processing station or operation. So this is an example. This is symbols used, as I said, schematic. When talking about schematic means that dia ada simbol, dia ada maksud. So proses dia akan guna kotak. Kalau sebut flow line guna arrow, kalau guna start ataupun terminator ialah tu dia guna macam bentuk ni. I forgot what this symbol is, like curvy rectangular. And we have to make decision, mana ada pilihan A or B, pilihan A, pilihan B, guna diamond shape here. Connector ada bulatan, inventor, okay, and so on. You can read this later on. Let's just go to our example. So this is an example, standard example. Kita ada start. So start, remember, dia akan mula dengan bentuk bulatan, petak curve edge here. Okay, and then process. So we have process 1, fill kettle. So that is your process. So you look here, ada penggunaan dia, simbol dia. So make sure you know where to use it. Okay, make sure that. And then we have the next process, heat water. Tak ada masalah, masih proses. And then now we have diamond shape here, so must be ada decision. Decision dia adalah yes or no. So kalau no, you ulang balik kat sini. You ulang, ada iteration. Okay, kalau tak ada, okay, dah yes, you continue buat make T. So process, and then stop, mana start dengan stop masih menggunakan terminator, maknanya penutup. Dia habiskan. Okay, masih gunakan shape ni. So here we have used all the this is the basic shape that we're gonna use. Okay, so right, so how do we use in our QC? How can we do quality control by using flowchart? So typically, now you know your process start here, and then you have process 1. So engineer, what we're gonna do, we're gonna go one by one. Kita akan go to each process. Kita check process 1. Process 1 apa dia? Fill kettle. So is there any problem? So kita mungkin guna cause effect diagram. Okay, cause and effect diagram. Kita guna Pareto on specific process. So basically you can combine the use of quality QC tools. You can combine them. Ataupun you can just go and then make some observation. Okay, check apa masalah dia dari segi masa, patutnya berapa, can we improve the time taken? Yes, can we improve? Yes. Okay, what to improve? And then you make some study, you make data analysis, and then you decide what to improve. So we're gonna go to each process. So process 1, again you go. Dah settle process 1, you go to process 2. You tengok pula apa yang boleh improve, and then you okay, improve. Next, dekat decision making masalah dia, alright, blah 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 blah, and then you improve there. So this is how we use flowchart. So we can know, okay, or your besides is a way of communicating to anyone. Kalau you nak buat kerja kan, you tak tahu nak buat apa, you tengok flowchart dia, you tahulah apa nak buat. That is number 1, communication method. Communication, you make sure people understand from flowchart. So this is easy to understand the process. Berbanding perkataan-perkataan macam ni lah. Okay, so it's easy. We're gonna see. Alright, okay. The next thing, we can use this flowchart to focus on each point here, each part here. Maybe awak akan nampak, kalau biasa kalau tengok cerita kartun, cerita kan, Awak akan nampak dekat sini dia menyala. Ting, 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 ting. So, masalah ada masalah dekat proses ini. Bukan masalah semua. Kalau awak kata, okay, ada masalah dekat nak buat proses ni, nak buat IT ni. Okay, so susah nampak kat mana sebenarnya masalah. But if you know, oh sebenarnya kat field kettle ni ada masalah, iaitu kettle dah bocor. Ataupun kettle ni dah rosak. Pemegang dia dah patah. I don't know. So, dia akan menyala dan awak akan nampak. So, dalam factory, manufacturing process, awak akan nampak macam ni. Ada benda yang menyala, ada benda yang dia minta awak baiki dulu. So, kita akan nampak lebih senang. Kat mana, dekat proses mana masalah. So, this really help. Mungkin kita nampak macam simple je. Alah, flowchart, saya dah biasa buat. Alah, benda ni. Alah, saya tahu lah ni. But in reality, it's really, really helpful. Very practical. Very make things very easy to do. 10 point. Okay? Alright. So, this part here, awak boleh tengok. Solve basic problem using the following QC tools. So, awak akan tengok macam ni dia gunakan Pareto diagram, check sheet, cause and effect diagram, and control chart. Yang lain tu awak mampu untuk describe je lah. Okay. So, this is example. Construct a Pareto diagram for replacement parts from an electric stove. So, we're talking about electric stove, dapur elektrik. So, the data is for 6-month period. So, oven door problem 193. So, saya garis kat sini. 193 oven door problem. Replacement part. So, oven door ni dia punya pintu ada 993 kali. Ada pembaikian ataupun digantikan lah. Okay. Timer dia 53 kali, front burner 460, rear burner 190, burner control 100. Okay. So, you don't really have to worry about the detail, but you want to know the numbers here. So, you can start make your Pareto diagram, and you're gonna have, you know lah, buat lah. So, sini yang Y dia adalah dia punya frequency, and here is category ataupun type, masalah dia, problem dia ataupun replacement. So kat sini awak akan ada start dengan I think front burner, and then next day, next day. Okay, so ada tak jawapan kat sini? Cepat je. Right, so this is an example. Okay, dan ini dia start dengan tengah sini. Remember the line here, show your cumulative percentage. Okay. So ini totalkan semua bilangan semua ni, and then you kirakan, bahagikan ini dengan total. This part, yes, this about 80 something divide by 100, the total frequency, total number of checks, and then you time with 100, you're gonna get the percentage here. You can get this percentage here as well, and then you kena tambah lah untuk dapat cumulative berapa. Alright. So this ada dua axis here yang kanan. This one is for your number of checks, and this one is your cumulative percentage. And then you're gonna have the check sheet. So ni contoh dia bagi awak, dia tak bagi contoh. Figure above show location plot. This one dia tak bagi awak problem lah, cuma dia bagi contoh je dia nak buat. Alright. Dia guna bentuk simbol supaya nampak. Tak, ini dia bagi soalan ni, cuba awak buat soalan je ni. Buat ni. Alright. So ini apa dia kata? Figure above shows a location plot of the indoor pane. Produce a check sheet. So kita buatlah dekat scarf ada berapa? 1, 2, 3, 4. So kita 1, 2, 3, 4. Do you have 5? Do you have 5? No, just 4. I think so. 4. I'm not sure, saya tak nampak sangat dia punya bentuk dia ni. But let's say run. Dekat run dia ada 1, 2, 3. 1, 2, 3, 4, and then 5, and then 6, 7, 1, 2, 3, 4, 5, 6, 7. Right, I think about 7. Okay, about 7. Okay, 7 ini. Okay, bulatan. Okay, let's start from the left here. Okay, sini dulu ni bulatan. So 1, 2, 3, 4, and then 5. And then kat sini satu bulatan ni saya rasa belakang ni 6. Dan kat sini atas ni 7. Okay, so things like that. So that's how you make your Pareto diagram. Alright, so buat control chart. Okay, ni buat control chart. Boleh kena buat kiraan lah. Berapa dia punya UCL dia 23.5. Ini dia punya, ini simbol ini min, simbol min. Ni simbol. Dia center atau ada tambahan tu. UCL, lower control limit. So dia buat kiraan lah. Plus minus. Okay. Alright, so this is control check example. So, boleh try buat. And I think that's it for your this video here. So remember, quality control starts and ends with training, meaning that once cannot do quality control without proper training. So awak dah, saya dah ajar awak ni, I hope you can be able to make some difference in your quality. Okay, alright, so that's it. Alright, thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and thank you very much and goodbye.